While we all love them, storing your code in a centralized Git repository cloud service means trusting someone with your code. Even on the repository level, each has just one owner. Today, there are millions of Git open source repositories, each with a single point of control. This is not very censorship resistant, nor it is secure, because you can have bad actors, you can have direct or indirect security vulnerabilities in them, and the more code you write, the more code you store, the more code you deliver, the less secure it is, simply because with every line of code, with every script you add, with every layer of container you build, you add to the entropy. And this is the reason why we started Gosh. Gosh is Git Open Source Hodler. And I'll try to explain what each of these words means. Of course, you know Git, and you use Gosh exactly like you use Git. That's why we said Git. You obviously know what open source is. And Gosh is particularly powerful for open source collaboration because it helps to manage the open source repositories like never before. As my colleague Roman will show you later, with each repository created on Gosh, there is a decentralized autonomous organization deployed. Some of you may know what HODL means. It's a slang meaning holding on to your cryptocurrency because it is the best value store. For us, it means, first of all, that Gosh is a blockchain. And second of all, that with Gosh, we want to help unlocking the value locked in so many open source projects. Gosh is a tool to build consensus around your code. So now members of the open source repository can use DAO, decentralized autonomous organization, for voting on important decisions, such as accepting new members or a merge into the main branch, for example. Because Gosh is building consensus around your code, you can now build tools around these repositories that can verify, encourage, and incentivize developers to actually look at the code and attest to its security. So the whole security marketplaces can be built on top of that. Now, you build all this using smart contracts, and smart contracts are composable, so they can talk to each other. Now you can actually rely on someone else's security assumption on someone else's repository, just by using this smart contract. This is why we're saying that in Gosh, the more code you write, the more secure it becomes. Now let's see how we can use Gosh, secure, trustless, decentralized Git development environment, to ensure the security of the whole software supply chain.
Our aim is to allow NFTs to be minted and sold not only on marketplaces, but directly in retail ecosystems, so that brands can explore NFTs in a secure way. The nature of the security services we provide means safety is top priority. We need to make sure that when our users deal with financial tools, their funds aren't in any danger. Adopting Gosh was an inevitable progression in achieving our security goals. Gosh technology can guarantee that our code is developed and delivered in a secure way, so software is never compromised. NFTs allow brands to expand their reach and grow their followers, to connect and create value. Together with Gosh, we hope to make NFTs a more accessible and reachable financial tool.
The aim of the Astropledge project was created as a means to reduce the risk of cyber attacks against space and terrestrial assets. And one of our solution's core functionalities is, of course, to provide self-healing automation procedures, especially for the software being sent and running into satellites cheap and board. So we use Gosh, of course, to build consensus around the code that we are uploading to the space asset. A consensus, of course, which often requires the highest levels of security and trust, of course, between developers, agencies, stakeholders, or sometimes even governments. So the unique challenges of space industries, as you understand, there can be a different satellite manufacturer, a different operator, a different payload integrator. So all these parties need to work together and come into a consensus or coordination between the different decisions that needs to be taken, which can be critical for the mission, for the success of the mission. So for us, it's inevitable to use Gosh as a core component in order to build on top our consensus procedures. So extending the Gosh protocol, we will be able to provide self-healing upon programming, configuration, and deployment of code versioning, keeping intact the CI/CD pipelines.
Let me present you our Gosh web interface. To start with, we need to create an account. A new seed phrase was generated for us. We should write it carefully and proceed creating account. Account is created and we now create new organization. Let it be Gosh DAO. The first participant is the default participant and it is organization creator. And you can add as much participants as you wish by putting their public keys into these fields. And for now, we'll create organization only with one participant. So organization is created, we mint 100 tokens for each user, and now we have only one user, so the total supply of the Gosh DAO is 100 tokens. Let's dive into the organization and create new repository. Repository is created and is empty. There is only one branch, main branch, and nothing else. Let's create new branch. As branch is created and is empty too, add some file to the dev branch. Let it be markdown file, put some header, some content. We can preview the result, put the commit title and commit optional, and commit changes. Now we can see that some file appeared in the dev branch. We can see the history, the first commit of the dev branch. Now, for example, we want to merge dev branch into the main branch. Let's create a pull request. We have our wallet balance of 100 tokens. Create merge pull request. We can see the diff between branches, the commit title, and commit out changes. Now we are pushing to the main branch, so the new proposal was created, and our wallet balance was moved to the SMV balance, and 20 tokens were locked as a fee for creating the proposal. We have some info about proposal, its status, votes, accept or reject, and let's look at the proposal. So we see here the same information, the form for voting and the diff, but data is going to be merged to the main branch. Okay, I think we can try again. Yes, voting time is active. And we can see our votes. So the list of all pull requests is here.
We have Docker extension built to validate images built from Gosh. Within this extension, you have full UI functionality where you can create user wallet, organization, and repositories. For this demo, I have created repository, and let's do some changes there. You can use any Git client configured to work with Gosh. Okay, let's modify sample file and let's push it. As you can see, it is as simple as working with Git.
I'll tell you how to build a verifiable Docker image from Gosh. Let's set up a few variables for convenience. We will need publisher credentials, Docker address, and an image name. Now let's clone a repository and see what's inside. As a Docker file, we use Gosh file YAML. First line tells us that we use our own Docker build kit frontend. That's because we need to control how the target image is built. While the build time, image has no access to the internet or any mounts except Gosh repositories. Now let's build our image. As you can see, it's a normal Docker build command, nothing fancy. We just add a few labels like publisher, public key, Gosh address, commit hash, so image become verifiable. Great. Now the last thing we are going to do is to sign our image. All we need is to specify a network, our wallet, our secret, and we need to calculate the image hash. Unfortunately, built-in Docker hash doesn't work for us. It's not always reproducible, so we have to use our own. Let's run it. And that's it. Now we have built and signed our image, and anyone can verify it.
Let's pull and execute this image. And let's check. Okay, we can actually run it again ourselves. Image shows this value. It's C9BA, and in the end we also have C9BA. So the image we built from the repository is exactly the same as an image we downloaded from the Docker Hub.